cool. Remove invalid parentheses. Remove the minimum number of invalid parentheses in order to make the input string valid. Return all possible results. Ugh. Well, that's a tricky one. Yeah, well, good luck, Alex. Definitely, these things are always tough, so I don't know. But cool. Okay, I mean, this is, I think in general, I mean, sorry, I just want to think about how I want to solve them. So in general, this is a dynamic programming problem. The kind of added complexity is that you have to return kind of all possible answers, which is part of dynamic programming. I think it should be fine. It's just yeah, just that you have to keep track of more states. The annoying thing, I don't know. Wow, there's 6 hints. I guess people have trouble with this, but the only thing that's a little bit annoying is that it doesn't tell you what n is, because I generally like to know what n is in general. But yeah, should be okay. So basically, so this is dynamic programming. The recurrence is the recurrence is kind of your left and the right is your endpoints, and then you try to basically take one to remove, and then do recursively figure out. Yeah, basically, or yeah, exactly. Do a left or right, and it's the well. So there are a couple of them where DPI, or is that an I? But yeah, I sub j, or left comma right, is basically the minimum that you remove to kind of the minimum you remove to where I to j is still a valid parent. So which I think just kind of just match a couple of things. There's some for loop somewhere. I think it depends what n is. I mean, not really, but knowing what n is kind of brings some confidence, and then you have to just be careful so that you could kind of input the or output the valid parent as well, which that might actually be a little tricky, but should be okay. But I don't want to start coding this. Okay. Let's say max is 1,000, but now then, if it's not, then I don't know. Also, in this case, I have to add a thing for. For keeping track of your previous best moves. Let's say we reconstruct here. We'll work on that next. And we just return 0, so that's our base case. It's just okay. Oh, okay, so since there's only oh wait, okay, so these are the parents, but there are non-parent e things, but there are no other type of parents. I hope. But okay. Then we could just do a counter, because otherwise you need a stack if they're more complicated parents. But should be okay. Okay. What is the recursion? Okay, well, one way is if this auto something, it's kind of making that confusing. Oops. And well, one possible case is calculate. So that's one possible solution. Maybe there should be a switch. Didn't really think it through yet, so might clean this up in a little bit. So if this is this, then a couple of ways, right? Because you could take the next one, so you have to try all of them. Okay. Yeah. Yeah, yeah, you're definitely right. I'm gonna keep track of it a little bit. I just want to get the initial, the minimum part right, because all these have the same length. I just because basically what you would do is kind of hook all these statements and then put them in the right way. I have a hook here uh, that I'll keep later for that reason, but yeah, I'll get to it. You're right. uh, Yeah, I mean, I think the reason why dynamic programming is popular is that you can ask a lot of things in a tricky enough way, and coding isn't usually that bad. It's the problem solving that is hard. Kind of, I don't know how I feel about it because it definitely is way more common in interviews than you see everywhere else. So I don't know, but and it's something that I personally also need to be better at. So yeah. Something like that. So there might be some. Yeah, should be okay. Because if these are not, if this is bigger than this, then this should be 0 anyway. So it should be okay, maybe. Let's print it out. FAQ. Um, uh, yeah. Well, at least this answer is true, correct. But oh, sorry. Yeah, I'm not like a professional streamer, if you will. So everything is very ad hoc. Feel free to ask me a question, and I'll just answer it. Though sometimes I get a little stuck being inside tougher problems, but I'll get to it as much as I can. A little bit. Oh, this is interesting, but the other one is right. But yeah, so I'm just doing some lead code to kind of make sure I practice on. And actually, if you go back um, like a couple, so I've been doing this lead coding streaming thing for a couple of months, and if you go back, you could see that I'm actually really I was really rusty, and now I'm slightly rusty, but it's slightly less rustier than with practice. So yeah. Why is this 1005? I probably just have some edge cases weird, but which is fine. Because when you do this, oh, because I never do. Okay, that's fine then. Yeah, yeah. No, I mean, I get that, Max. I just wonder why. Like, I think okay. In this case, we remove. I guess in that case, actually, I could. Like there's some stuff we can try, but I just want to see if this fixes it. Oh no, I mean it is definitely probably a frequent question. I should probably frequently put it somewhere, or like put it somewhere frequently or whatever. Oh, see there you go. But yeah, I'll probably put together something on Twitter. So I don't know. Like I said, this is not, I don't think I would do this forever, or at least, I mean, at some point I run out of farms anyway. So it's just something that I actually do enjoy, and I don't want to make like my career is a software engineer, so I don't, it's not gonna. I'm not trying to be like the next cool YouTube tweet, Twitcher or whatever. So, but I do enjoy this, and my friends are like, "Oh, you should just put on stream." I'm like, "Yeah, why not?" because having one thing is also that it forces me to talk through my problems instead of just like banging on the keyboard. Um, so that like in that sense, it more closely approximates an interview because so I don't know, just good practice. But yeah, okay. So now we know that this is true-ish, hopefully. Then we could kind of put these things here. Okay. Yeah. Mm, yeah. Is this right? What am I doing? That's not right. Eh, what is the previous? Hmm. Maybe something like that? I don't know. We'll see. But this is right. Okay. Uh, oh, wait. Yeah. Okay. It's just a lot of bookkeeping at this point. That's all. Oh wait, this is actually not true. I need to also clean up this code a little bit. I think. I think this is actually the default case, even though. Well, it's a default case if it's not if it's a paren. Okay, fine. Okay, I'll just do it a bit. If, well, try. Okay, let me just do the copy and paste, and then once that's correct, we'll dry it because this is ugly as heck. And also, that's not actually how I want to do the reconstruction, the path reconstruction, maybe. Man, maybe that's the hard part. Let me think about this for a second. Yeah, at least we have the paths right. I think you just have to set up how to kind of connect it in a way so that you can backtrack it and then so forth, which is a little annoying, it seems like in this case. But so what does a previous mean? So this means we take out left and I. I should probably integrate this. Yeah, I mean that's essentially what I'm doing, but yeah, so you have to kind of do some bookkeeping to kind of show your work. So then here you could just do some kind of. Usually I do it recursively, but you don't have to kind of reconstruct the path. So the tricky thing with this one, in general, in general, you can, yeah. I mean, I also, yeah. In general, sometimes they only ask you for one solution, and then you don't have to do anything funky. But in this case, you maybe have to do a little bit. But you're also maybe right. Maybe I don't need to do all the. But then you would have to like copy this code mostly to kind of reconstruct it. So it's a little weird. So what I'm doing now is kind of caching those pieces, hopefully, so that like when you do the reconstruction, it's a little easier. Um, Well, maybe I don't have to. Maybe you're right. Maybe I just store all the possible arrays. let me think about it for a second. Because usually it is not memory. Because if you just because in general, in general dynamic programming, if you need path reconstruction, you just store the links to the previous piece, almost kind of like storing your back edges on a graph, going through a graph and so forth, right? And usually that's fine because it's not memory intensive. You usually only store a couple of links, and it's of the number of edges of y. But where if you like store the entire path on each node, then like it's O of y times your longest path, which is I guess possibly v, so it's v times y. So then you have another like O of n storage thingy. But yeah, maybe I could just code this in a different way actually. Okay, so let's code this in a different way. Okay, I mean, I'm going to add some annotations because I'm going to forget. The probably, though I would say the clean way is probably just to like make these objects. Then I don't have confusion about what they are. But in this case, okay, first index is operation. The second index is the well, it's actually the literal index of the matching right paren. And in that case, let's just yeah, well, I think it's 0 maybe it's fine. Maybe this should just be -1. Because we get a 0, we just go to the previous. We'll have to see. I don't know. How to drawing the graph from scratch. It's a little messy. And maybe we should use enums. But it'll probably be just a lot of these. Okay, and then now, previous. My vocabulary name is terrible. Also, this should be a vector then. Let's just see if it compiles. Okay. So now we have to walk the graph. Yeah, I'm going to do a kind of dubious thing, but whatever. Of just having a global return result thing instead of because the clean OOP way, which I support in general, is kind of to pass the result around, but then I don't know, there's some stuff that may or may not copy by value, and then you have to put stuff on the stack trays and just ends up being inefficient. So I'm going to do this for now. What am I reconstructing? I guess this is just void then. There probably is a cleaner way to do this, not gonna lie. But you're here with me. Oh. At least we make it earn its difficulty, I guess. Okay. I just sort this anything? What's that? I wonder if there's a lot of, now that I think about it a little bit, I'm just also a little skeptical because maybe sometime, I mean, I think we have to make sure I dedupe a little bit. Because the different paths that the way we construct the way that we construct the array, there are definitely different paths that kind of do the same thing, if you will. Because let's see, I guess it's only this operation. But there's a bunch of these. So okay. Well, let's start by seeing what we're doing with here. Yeah, I mean, I'll probably end up throwing it into a set later, but I also just want to yeah, practice this stuff. This stuff is kind of tricky. I guess I don't need. It's a little tricky to get right just because I'm not quite sure. But I guess that's why it makes it good practice. So next time I do it, it'll be okay. Okay, so what is this? Oh, that's the index of the thing that we combine. So okay, that means we use this second index as so that means, what does that mean? That means the character here matches the character at S of left. Okay, could do that. And also, I'm also just thinking right now. I'm just thinking about also a quick optimization because I don't want to construct like 80 billion strings. Yeah. Yeah. What is? Well, I guess we still don't know what the max n is, but yeah, if it fails, it'll be funny. Kind of. Maybe it's a character zero. It's kind of weird. But yeah. Okay. That means S of left is equal to this. Oops. S of oh, I don't know why I said S, but it should be cache. Actually, that's not. Oh, actually, no, that should be okay. We could just do some maths. Can we? Nah, it's a little tricky. Maybe this is an ill-advised move. Maybe I'll just do the string way, and then, because I think there's a lot of potential for off by ones. Excuse me. I think. Basically, you have So yeah, this, maybe I should use a string buffer though, but plus we can, it's not quite what I want to do, but your string is something like this. Oh, it's not I. This is not real syntax. This is like pseudocode right now, but just for me to think through. No, you remove the, so it's this. Okay, so that's your string. Maybe I do need to do some crazy recursive thing. Yeah, maybe this should return a set just to make it easy for me to write the recursion. So in that case, I could just use that, so maybe that's fine. And now we have some for loops. Maybe, yeah, okay. But yeah, this is why I didn't want to do this like the root solver, to be honest, because then there's a lot of people just watching me type, and there's really not super much to kind of for me to articulate or learn. Yeah, I mean, maybe in the future anyway. But okay. Yeah, okay. I guess I actually don't need this anymore. I can just do back to. There might be libraries that already do that, but I am not familiar enough to do it without looking it up, which is fine, but I just want to focus a little bit. Maybe that's enough. Well, no, that's not enough, but that's enough for the if else. You just return, well, you have to do it. And this is why it's a little, little sketch. I wonder if this happens more than once, actually. so that we could actually remove some duplicate work. It probably does, so I have to do it in a little bit. Let me finish that. Because actually we could see it. Oh, -1. Oh, yeah, because we don't use a second index. Oh man, what am I doing? Yeah, I got too many weird things in my mind. Oh, is it insert? Is it what happens when you use different languages? Oh, there's no base case. Where's the base case? Did I not? Sorry, I just read your comment. But, I mean, it's definitely very annoying. Like, I think conceptually it's okay, but I don't know. Okay, I guess actually you need yeah, yeah. Also return. Well, something. Also, what the heck? Oh, because I always return stuff. Instead, oh, I don't do the removing. That's why. Uh, I just want to check my case for if this is an alphabet. So actually, this is maybe missing a case. What's my base case? I guess my base case is do nothing. How is that right? Maybe this is where I use this second index. Does that only move it? Okay. Fine. But yeah, the dynamic programming was an easy part, I guess. But well, relatively. I wouldn't even say it's easy. It's just easier than what I'm doing now. And now I forgot what I was doing. Oh yeah, because I did this. I encoded it. I should have commented it. Or this is also where having real class for this node is better. But if this is 0, we keep this if it is 0. Then okay. Otherwise, we actually remove this letter. So we just actually, yeah, I'll fix the indents. Hang on. Otherwise, you don't use that letter, so you just insert it. It's still wrong though, but hopefully it's less wrong, which is, a step at a time. Okay, that's good. Don't know if it's necessary, right? But okay. But why are the other stuff not constructing? I probably missed an if statement somewhere. This is not even okay. I put in multiple cases. I guess I did. I'm about to print a lot of stuff. How did I do the substring thing well? I think this is lang. I always forget it if it goes from left to right or whatever, but though you would imagine it just has more stuff. What is this? Oh, that's fine. How does that happen? Oh, I see. Because one of these could be empty. Okay. Because in okay, fine. This is so frustrating. Okay. I mean, if you know what to do, it's half the battle. The other half is doing it. Then we just test the case, then you just insert the second half. Oh, yeah. It's a lot of copy and pasting, so I'm gonna have to clean this up. Just maybe there's a easier way. I would say I don't know if what I'm doing is like the cleanest way. Okay, well, that's a start. Uh, hmm. That is weird. Maybe. I don't think of Go. Actually, I guess I can do this. Also, in the real world, I guess you would want to debug it and just step through it. But life is tricky. Thanks for staying with me. This is it's a lot of typing and minor debugging because typing things incorrectly. Okay, that's good. This is better. No, I just had something bad, but so for 4, 6, 1, 2, 3, 4, this. Do I have this backwards? No, it should be right. No, because you. No, this. Yeah, it should be right. Maybe. Or at least. Why did I remove so much stuff? Oh. Where did these strings come from? Am I inserting the right things? This should be a string, right? Like, am I just doing something silly somewhere? Alright, let's just do something simpler. And then I'll kind of build up a little bit why things are weird. Well, at least that's good that that's wrong. Then we can figure out what it is about it that's wrong. And 0, so it doesn't even go to here. So it's just one of these base case E things. No, maybe this is +1 actually. Actually, I was thinking about that, but I forgot to follow up on it because I don't know. It's very long code. Okay. Okay, so that makes me happy. Let's see this. Well, that happiness was short-lived. Okay. So 2, 2 returning nothing, that's reasonable. Also same for 1, 1, but still 2. What are you doing? You should print some stuff. Why does it even have an empty string? Because it might not have a previous, but then we force it a little bit. Okay. Wait, is that true? No, I don't know. Maybe I just babbled on that one. But still 2 should have a previous, right? That's 2. Why is it not printing anything for, or why is it not inserting anything for results? Can this be anything else to have a typo somewhere? Well, I only do like, two, 1, 1, so that should insert stuff. Did I reset it somewhere by accident? Because that would be funny. Should be here. Yeah, if this is, oh man. Ugh. If that's the reason, well, that's the reason I'm half happy that I find it. And if that's, well, I mean, that's definitely wrong. But, okay. But if, well, I'm still half happy, but still a little sad if that's the reason that it took me so long to debug, because I have a typo. Yeah. And that's what happens when you have 200 lines of code. Typos creep in. Okay. Let's do something slightly more complicated. I'm crossing my fingers. Okay. I mean, I don't know if I need to sort it or anything, but let's try the other one. Sorry, friends. I'm a little tired from just grinding on this one, but hopefully it is right, so I don't have to at least be unhappy about it. Okay. One time seems okay. YOLO? Maybe there's an edge case I haven't considered, but I'm a little tired, so I'll let the system testing decide whether I missed something or not. Okay, friends. All right, that was a little tiring, but at least it's right, because if it was still wrong, then I'm a little sad. And it's very slow because I do a lot of string construction, string concatenation and stuff like that. So I create a lot of instances of string. I mean, I think so. Well, what I'm telling you now is probably what I would talk to the interviewer about. Like, yeah, maybe I'll use string buffer or what equivalent. I actually don't know how to do that in C++. Or I mean, I haven't thought about it in C++, but like there's some math you can do. Or maybe if I thought about it ahead of time, I would use like C# or Java with string buffer or even Python, right? Excuse me. So that solves a lot of one-time things. A lot of memory things, which also probably ties back into the one-time things. I think the recurrence. I think someone called out very quickly actually. So it wasn't like I don't. Yeah, all the smoke called it out way earlier. Um, so like the recurrence itself is kind of I wouldn't say standard, but it's something that you practice dynamic programming, you'll see these kind of very similar problems and kind of like yeah. I mean, I wouldn't say it's easy because these things just takes a lot of practice to make it feel easy, quote unquote. Even me for now, and I practice a lot, I still have trouble sometimes with certain dynamic program problems, and on an off day, I still don't get them. On a good day, I do okay. The thing that makes this problem tricky is obviously you have to reconstruct the path, which, and I actually have, and I know how to do it, and I've done it before, and I made a mess of these things. So I think the first thing I would tell the interviewer is kind of figure out how to make things cleaner. Obviously, there's some stuff that's just messy, but I would first of all I would there are a lot of oh yeah sorry I would definitely get into it. I think yeah, first of all, what I would say I would do is I use pair into interline, which is just a way to kind of put a couple of integers together. But if I were to, let me just save this number first so I could mess around with it without kind of not having the code. But if I were to kind of write it in a clean way, and I don't know how long did I take? So roughly an hour. So a little bit on the long side. I could have been shorter, but there's a couple of minor silliness here and there. But like I would maybe write a class that's like class. How do I do this? Maybe edge something or previous edge. I don't know, something that naming is hard. So, but I will get to it in a second. But then you have like int or maybe even a unum if you want to be precise about the what the previous step is. But let's just say is without because I don't want to type too much. So you have two types. One is and I definitely should have explained it a little bit better, but I just wanted to also make sure that I get it right first. Because there are two different previous edge you can take, right? One is well, given the beginning of the string, which is index left, you delete that left, right? Or you delete that character at index left. So that's where we get the oh. So then let's say we removed this character. Then your recursion is just your string minus that character plus 1, which is the cost of removing that character, right? And this is just to kind of keep track of. So I hope this part is clear. Like if best is if and you're trying to find a min. So if the min is with your current best. Oh, yeah, let me restart a little bit. If your current is if you could do strictly better than your last result, then you just you clear it and then you push it back. And if it's tied, that means you have like in some other similar problems you may have tiebreakers, but in this case you actually want to keep track of all the ties, right? And I kind of just put 0 as kind of the enum, if you will, for removing this character. So 0 means we remove the left. We remove the character at left. Yes. Ask me questions. I know it's a little wordy, so I'm trying to say it precisely, but also just without being wrong. So definitely, but yeah, I could try to explain it a little better. I mean, I could also just explain it really slowly. I don't have to, I don't have anywhere I need to be precise. I don't, but so that's kind of the first character. And second character, I just had a placeholder, which I actually end up using later, which I'll explain in a second. So that's what happens when my first character is 0, which means this is like, you can say like in type or enum type or something like that. And then the second is like almost like a second type, which I kind of abuse in two ways. So you want to think about it in a, yeah, maybe I should have done it in a Python or Go. Because then you could write class in a more straightforward way. It's my bad. But you could actually think of this as like this pair intent, just a union class of two things. So if type is 0, meaning if it's removed this, if it's a removal type, then actually this is then, yeah, if it's -1, then you actually remove it. If I actually end up using this later to encode 0 for basically if it's not a paren, then you keep the letter, right? Like in this case, in example 2, you actually want to keep the A, so you don't remove it by accident as part of the shortest path. So that's the two kind of, so that's what the second flag is for, even though I use it in two different ways. So you would maybe do a enum. Maybe there's like two, like if you want to define it more precisely, there are probably a couple of ways to define it. You can actually set this to 0, and you have one here, and then maybe this, you could just use another enum, maybe like 2 or something, right? So that so this is for progressing but keeping the letter. So you have 3 different types. You have keeping, you have removing the first letter, and then you have the third one, which is you remove parens together, which is what this chunk is doing. And it uses the index I to keep track of where on the second paren, I don't know which, this gets mirrored, so I forget which, but the end paren is, right? So that's kind of the how I construct the graph on kind of in like, okay, now given a left and a right, this will store a list of things that are tied with the best, right? The route that you took. And then the reconstruction is kind of working backwards from that, right? And I'll go for a little bit, and because what we got Twitch over here is kind of alluding to this. My code is a mess. I'm not gonna lie. I mean, I kind of did it so that I could see to get it working, and you kind of saw me kind of work on this incrementally. So kind of keep on adding little stuff here. So like now it's just a mess. Like if I know how to solve this, and if I knew this is exactly it, then I would have done some of the cleaning stuff, and definitely in Python or C# or something like with cleaner OOP and data structures already, then like then these would be more straightforward. And maybe I don't know if I want to spend all this time typing it out, but going for the reconstruction, well, okay, let's say you have a left and a right, then you have these best case, best case, whatever, they're just base cases, right? So like this case, that means that you have an empty string, so it is what it is. If everything within left to right is already good, then you just like that's your full string, right? So those are your two base cases. Yeah, regex is powerful, so I don't know, but I don't know if this is a regular expressionable thing, but yeah, but now going through, so this line 108 is kind of what I have, like all the previous edges that are like, okay, so these are all the steps that got us to the current state, and you have like a list of them, which is why I go through them, and then you have this case where, okay, you're matching the left paren, which is at index left, with something in the middle, which is for some index that we store, which is, let's say I, which is in the second index of the array, which is sorry, it's a little messy, or a lot messy really. And then in that case, there are a couple of cases where we're like for this example, you have, if it's just like the first character, then there's nothing in the middle, and then it's like a lot of junk here, right? Junk. So that's the case for this one. And then here it's kind of opposite where it's like wrapping, totally, junk inside and so forth. Where this is the more general case where you have, you know, oops, junk and junk. Where junk is, I guess maybe junk too. You want to be more precise, and those are kind of the things that you get from the recursion, and you have to iterate through them to get all possibilities, and you could kind of tell that lowest n square. But I actually don't know what. I guess we never found out what max n is, but which is less than 1,000, which is great because otherwise I don't know if I could make it fit. I mean, we talked about some ways to make it fit in time, but yeah, but that's kind of the reconstruction, and then the recursively, we just kind of if you think of. I don't know if you want me to explain like path construction in general or like this particular case, because I think it's much more easy to demonstrate this on an easier problem, or at least a problem that doesn't require multiple output, because then you could kind of think of it. I think there are probably YouTube videos, but if you look at path reconstruction, then you kind of have like, okay, so I'm at x comma y, and then now I'm at and the previous, like you can draw, if you will, an edge from that to like a previous node, which is like, I don't know, A comma B, right? And then you kind of keep on recursively doing it that way by either DFS or BFS and so forth. But yeah, it's definitely, it comes up from, I wouldn't say it's common. It's probably not common in general, but it's something that comes up from time to time, as you can see. But yeah, I would recommend kind of looking for YouTube videos. They can explain it a lot better because they have better visualization. Because to be frank, I'm not I don't know, I don't have like an iPad or whatever. But yeah, but basically any dynamic programming problem, you can. So I think what ends up happening is a lot of dynamic programming problem ends up being an optimization problem where like, you're finding the max or the min or the sum or whatever, and a lot of these problems they set up so that you only need the answer, but actually like if you actually use this in the real world, just the answer is not, like it's not sufficient. Right? It's like, it's nice to know that that's the shortest path, but like if I'm getting from my house to your house, like, yeah, okay, like it's good to know that it takes 10 minutes, but can you tell me how to do it, right? And that's where the path reconstruction actually comes in, and it's kind of standard ish that like I think you can YouTube it and it'll let you know how to kind of like visualize it in a better way, and then programming it in a clean way, because this is definitely not I mean, this has all the concepts of classic path reconstruction, but I definitely do it in a very messy way. So like I wouldn't like this should not be a reference to anything. This should be taken out and shot. But I think so. If I was an interviewer and I'm faced with this problem, one is I'm going to curse the interviewer under my breath and be like, why are you giving me this hard problem? But but I would also make sure that communication is important. I mean, it's important. I mean, it's unspoken, so it should be important anywhere you go and everything you do. But kind of make sure that you set the expectations. Like, hey, I know that the code I'm writing right now is going to be a little messy because I'm still like, because I just want to get it right, and that's what I'm optimizing for. And then we could clean up the code afterwards, and making sure that it's okay. And sometimes, and making sure that they understand that, like, look, this is not going to be my final code. If I ever showed anyone this code, if this is shown as like my regular code or my regular work, I would not be part of it. I'll be like, I don't know. I'll be super embarrassed if nothing else. But this is, maybe reasonable code for an hour of a hard problem that took 174 lines, give or take, including, having to figure out how to do it. So I don't know. So I think like it's worth. I think that's the number one tip I have for these things for problems that you think is hard. It's kind of like making sure the expectation is right and be like, hey, if I have time in the end, we'll clean this code, or at least we'll talk about how to clean this code. Because a lot of the times, like, I don't know. At least this from the other side. So some interviewers will always be a little harder or whatever, or easier depending on who you get, and sometimes it's, they have a bad day or whatever. But for me, when I'm an interviewer, I so there are a couple of different types of interview or different uh, uh, I don't know what the word is, but like they're testing you for different things. And if I'm asking you this problem, well, one is I probably hate you, but two is also well, like what am I trying to get out of? Well, what am I trying to learn about you, right? And for this problem, for me, the focus should be problem solving, like algorithms or whatever, and 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 if that's the case, like, yeah, it's nice to have clean code, and given, I wouldn't say unlimited time, but like given sufficient time, like we can clean this up a little bit and so forth. But then, so what I usually do in my interviews is that I'll be like, okay, yeah, this code is fine, it's great. Now, like, let's talk about like how you would, make the code cleaner or make it ready for production. Let's say you're trying to productionize this code. What would you do, right? And that's like a weird, and that's only if I have time, right? Um, so and then we could talk about it because I don't like for example, like maybe we could rename some variables and it was just fine. But I don't need to spend 10 minutes watching you, renaming variables. That's not a good use of my time or your interview time and so forth. But like I rather go, think about how you approach code and so forth. So I think that's my spiel, just to kind of set expectations. And I know that, like, that said, if I ask you like how you would improve this code, and you're like, yeah, this code is great, I would do nothing about it, then that is actually a red flag, or at least like I would not be happy about it, because you should be like it's okay to know that you're under pressure and you know what you could go back and change if you had the time, but it's another to be like, no, So I think that's kind of my rant. And yeah, as I kind of alluded to, I don't think this is a little, or maybe a lot too hard for interviewing. I don't, especially, yeah, especially for, something that should fit within an hour. Um, I don't know if there's I mean, I would say this was probably the right difficulty if you don't have to do the path reconstruction. I think it's a standard-ish problem. But again, going back to what we solved on the medium, I think I think it is a little tricky in the sense that yeah, maybe there's a take home or something. I hope so. I mean, I don't know. But yeah, I think the problem with kind of these and dynamic, I generally don't like asking dynamic program problems. I mean, some people do, and it's fine. It's just that like a lot of the dynamic program problems require you to like either know it or you don't, which is not something I want to spend an hour on. Like I could ask you questions, and I don't know, like it is like I don't know how I can give you a hint that is that you don't already know. Like if I just like if you don't know dynamic programming or you don't know this particular type, maybe like maybe if you know dynamic programming but you don't know, or maybe you just get stuck a little bit, then I can nudge you a little bit. But I don't know how much that, how far we can nudge that. So I think I usually ask more, yeah, like a different type of problems. But I think if I were to force, or if I were to feel like dynamic program problem that day, then I think this is probably a reasonable one, minus the path reconstruction. Like, uh, like if you're just doing the min, then yeah. But yeah, like I think exactly. Yeah, I think I don't know. I don't think I would ever find it that fair, to be honest, because it's like, well, yeah, if you're good at dynamic program problems, then it's fine. But like I don't know how that's good at like what does that mean as a software engineer? I don't know. But that said, I don't know. But yeah, I don't know. But I guess my thing is I probably this is not my type of problem, but by itself it's probably good enough, or like it's yeah, it's like a general dynamic or standard-ish dynamic programming problem without the path reconstruction, which maybe I could have cleared up or done a little faster. I had a really silly mistake where I just had a typo. So that took like 10 minutes, or maybe not that long, but a couple of minutes, which is a little sad. But